அனைவருக்கும் வணக்கம். Today we are going to discuss the unit for magnetic, dielectric and superconducting materials in the material science paper. So in this unit 4, now we are going to discuss the first topic, the ferromagnetism. What do you mean by ferromagnetism? That's the thing we are going to discuss today. The first topic is ferromagnetism. This is the one we are going to discuss today, the magnetic material. Already we know the different type of magnetic material: diamagnetic, paramagnetic, ferromagnetic. The diamagnetic due to the paired electrons, because all the electronic shells are in paired. If it is in paired manner, then those material are called diamagnetic material. Even if you are applying the external magnetic field, it will opposes the magnetic field. That means the net magnetic moments inside the diamagnetic material goes to zero. Similarly, the paramagnetic material, if there is a single unpaired electron in the magnetic materials, in the magnetic material, the atoms are having single unpaired electrons, then those materials are called paramagnetic material. If you are applying the external magnetic field, what it will do, the single unpaired electron, the spin is aligned in the applied field direction. So we are calling those dipole moments are aligned in the external magnetic fields. Those materials are called paramagnetic material. Even if you switch off the external magnetic field, the magnetic moment will go away. It will align in random direction, all the magnetic moment. Once if you switch on the external magnetic field, all the magnetic moment are applied in the field directions. So those materials are called paramagnetic material. But in the ferromagnetic material, if you are taking the ferromagnetic material, if you are observing that one, you will see lot of unpaired electrons. Example, the ferromagnetic material example, if you are taking, it's iron. It's a best example. So iron is having the 26 electrons in its outer orbital. That means atomic number of iron is 26. Atomic number of iron equal to 26. So how many unpaired electrons in this iron, if it is there, means just we have to fill up the electronic levels. So the first orbital is 1s orbital ion. It will be having two paired electrons. The next orbital is 2s orbital. So you can just erase this one. Yes. So next one is the 2s orbital. The next is 2p orbital. The 2p orbital is having 3 electronic energy level. They are degenerate energy level. This is 2p orbital. Each of them are having 2 electrons. I will fill up the electron. First I want to just draw the energy level. Next one is 3s orbital. Next highest energy level is 3p orbital. Next one is 3d orbital. 3p orbital usually having 3 energy level. D orbital is having 5 energy level. 1, 2, 3, 4, 5. Then 4s. I think this is enough to fill up the 26 electron. Now what it will do, the 26 is an atomic number of the ion. So first we can fill up in this 26 electron, 2 electron. One is upspin, another one is downspin. So the 1s orbital is filled by the paired electrons. So the net magnetic moment is zero, because one spin is up direction, another spin is down direction. So the equal and opposite dipole moment, it will cancel each other. So zero magnetic field contribution from the 1s orbital. The 2s orbital is having two electron with opposite spin. So 2 plus 2 is 4. The 2p orbital, first we have to fill up spin, then down spin. It is also filled with six paired electrons. Two of them are paired with up and down spin. The three s also is paired with two up the electron, with the one is up spin, another one is down spin. Like that, 3p also it is this energy levels are also filled with the paired electron up and down spins. Then 4s. Because we have to follow the Coons rule to fill up the electronic energy level. So it will go next level is 4s. Then the remaining electron we need to fill in the 3D orbital. Here how many electrons filled means 2, 4, 4 plus 6, 10, 12, 12 plus 6, 18, plus 2, 20. Almost 20 electrons we filled in. And in the 26 the remaining we have 6 electron. First we need to fill up spin 2, 3, 4, 5. Then one more. Now we need to fill the down spin. So here in the 3D orbital, the first energy level is filled by the paired electrons. So there are four unpaired electrons in the 3D orbital of the iron atom. So four unpaired electrons in 3D orbitals. So these four electrons contribute the four magnetic moments. These four magnetic moments it is aligned parallel to each other. It will create the magnetic field for the single iron atom. But if you are taking the material, there will be a lot of iron atoms. So each iron atom having four unpaired electrons. So all of them are paired. Maybe the suppose if you are taking particular iron atom, if the four unpaired electron, it will create the resultant magnetic field in the particular direction. What it will do? It will do the nearby atom also. It will try to spontaneously stimulate the magnetic moment in the parallel directions. That means, suppose if you are taking the iron atom here, there is four unpaired electrons. All of them are paired in the same direction. What it will do? It will induce the nearby iron atom also, the unpaired electron, try to pair with parallel magnetic moment. That's why the ferromagnetic material is spontaneously magnetized. Even without the external magnetic field, there will be a spontaneous magnetization in the ferromagnetic material. So, what is the ferromagnetism means? The unpaired electron create the magnetic moment. It will create the resultant magnetic field. This resultant magnetic field causes a spontaneous magnetization that is called ferromagnetism. So the unpaired electron, the unpaired electron aligned to each other to create the magnetization in the material even in the absence of external magnetic field. Even in the absence of external magnetic field. This material is called ferromagnetic material. This is a short definition for the ferromagnetic material. Now, how we can just tell, because a lot of books are drawing different diagram. If you look at the books, what they will given, just they will give like that. They will draw this is if this is the material. So there is a spontaneous magnetization. All the spins are aligned in the parallel direction. This is called the ferromagnetic material. So, in the presence of external magnetic field, this is spontaneous magnetization. This is called spontaneous. Spontaneous means without any external field. Spontaneous magnetic or magnetization. Now, what are the properties of ferromagnetic material? You can ask. What are the properties? There is a spontaneous magnetization, so you can tell spontaneous magnetization. The permeability of the ferromagnetic material will be large. So the permeability of the ferromagnetic material. Permeability means here I am saying mu value is greater than 1. Less than 1 means it's a dia, equal to 1 means para, greater than 1 means it's a ferromagnetic material. Then the susceptibility of the ferromagnetic material, it will be huge value and positive. The chi. This is called the susceptibility. Maybe you should know the basic definition in the magnetism. So I'm not teaching the basics here. So the chi, that means susceptibility of this material is greatest and positive value. So, in the presence of external magnetic field, all the magnetic moments are aligned in the field direction. So, in the presence of external, you can add one word external magnetic field. All the magnetic moments aligned in the field direction. That means how we know means suppose if you are placing the ferromagnetic material here, if you are applying the magnetic field, maybe you can take the north pole is here, the south pole will be here. So if you are giving the magnetic field is emerging from the north and ending towards the south, what you will do, all the magnetic field lines are passing through this ferromagnetic material, so it will be passing. So that means that it will be strongly magnetize the ferromagnetic material, the external field. So what do you mean by that? Means the inside the center material it will be perfectly aligned. That means the external magnetic field, all of them are passing through the external magnetic field. So if you have to look at the magnetic moment in this ferromagnetic material, all of them are aligned in this applied field direction. So that means it's strongly magnetized. Even if you are placing the ion in the external magnetic field, what it will do? It will get magnetized. So used to one word the susceptibility. What is the definition for the susceptibility here means for the ferromagnetic material? Maybe I can put the point here. The susceptibility is defined by some constant. This is called Curie constant time, the temperature of the material minus theta. So here C is a Curie constant, Curie constant, theta is the Curie temperature, Curie temperature, T is the temperature of the material, temperature of the material, the present temperature. What is this equation conveyed to us means if the temperature is keep on increasing, the temperature of the material, the denominator if it keep on increasing, the chi, the susceptibility, it will go down. That means the magnetization, because the susceptibility, another definition is it's equal to magnetization versus the applied magnetic field. M by M divided by H. If the susceptibility goes down means the magnetization is goes down. That is the meaning of the temperature increasing. This is the meaning of the susceptibility. So Curie temperature means it's a transition temperature where if the temperature of the material T is greater than Curie temperature, then the ferromagnetic material will become the paramagnetic material. So how we can understand means just you need to draw the diagram. This is a temperature, maybe magnetization, or you can put the the susceptibility of the material versus the temperature. So what it will do, if you are increasing the temperature, the chi value it will keep on decreasing, but at a particular value of temperature that is called as the Curie temperature of the material. Because the Curie temperature it will be different for different material. This is called theta. After the particular temperature, what it will do, it will become the paramagnetic material. Up to this region, the susceptibility will follow T minus theta. After this theta, the susceptibility equation it will change to the paramagnetic. Maybe there you can call this some constants R E some B. So it is proportional to 100 by T. This is a paramagnetic susceptibility. So theta is the transition temperature. What do you mean by the transition temperature means from the ferro to para. So here it's called the ferro region. This is called para region. So x-axis represents the temperature. If the temperature is keep on increasing, what it will do? So the paired electron it will vibrate with each other because the thermal vibration it causes a random orientation of the electron magnetic moment, electron spin. So even if you are increasing high temperature, what it will do? The parallel magnetic moment will be breakdown. So what the strong magnetization will be low, so it will become the paramagnetic material. So theta is the transition temperature. So these are the some few important property of the ferromagnetic material. The another important property, if you are look at that ferromagnetic material, I think almost we said enough information because the susceptibility will be huge, positive. The permeability also much greater than one. Then It's spontaneous magnetization. It is then it is having a lot of unpaired electrons. So the unpaired electrons will be huge. The electrons in ferromagnetic material will be large. So these are the it's some important characteristics of the ferromagnetic material. Thank you all.